Hello, today we will present our project in the title of Development of Lysophora apiculata planting pattern to enhance survival rate, growth rate, and mitigate coastal erosion for sustainable mangrove restoration. My name is Vermin Home, and my partner is Mr. Detective Wadi Pashu. We're from Business on site high school ground.
Mangrove play a critical role as robust carbon storage site and breeding ground for aquatic species. Unfortunately, these ecosystems are declining due to human activities, leading to severe coastal erosion, global warming, and economic challenge for community. While reforestation is common, the lack of a structured planting plan often results in low survival rates, as seedlings are highly vulnerable to water force. To address this, development of Rhizophora apiculata planting pattern to enhance survival rate, growth rate, and mitigate coastal erosion for sustainable mangrove restoration.
The next is the research question. 1. Does the planting pattern of mangrove affect its survival and growth rate? If so, how? 2. Does the planting pattern of mangrove affect the soil properties in the planting area? If so, and how? 3. How do different planting patterns of mangrove contribute to the reduction of coast erosion? The hypothesis. Different planting patterns of mangrove trees result in variations in survival and growth rates. Soil properties are expected to differ significantly between pre-planting and post-planting periods under various planting patterns of mangrove. Diverse planting patterns of mangrove have different impacts on the mitigation of coastal erosion. The research objective: to investigate the impacts of different planting patterns on the survival and growth rates of Rhizophora apiculata, to evaluate the change in soil properties before and after the implementation of various planting patterns, to assess the effectiveness of different planting patterns in mitigation coastal erosion. Research variables: independent variable, planting patterns of mangrove. Dependent variables: survival rate, growth rate, coastal erosion mitigation. Soil properties: control variables, number of saplings, experiment site, plant spacings. And this is the equipment that we use. The methodology: 1. Site exploration. Explore the site in Trang province of Thailand. 2. Site selection. We select the site that in Sigao, Trang province. 3. Experiment design, planting preparation. We design 3 patterns of the mangrove. 4. Sample collection, soil analysis, data entry by globe. 5. Field plantation. We plantation the mangrove and the beach of Sigao in Trang. 6. Monitoring. And 7. Data analysis. Exploring mangrove forest in Trang province, we explore in the delta of Sigao River in Trang province. And then we select this site for our project. Design configuration and mangrove planting preparation. So we plan and we design 3 patterns of mangrove configuration. 1. The grid. 2. The star grid. 3. Half circle. And then the 4 is the control. It's the random. So plant mangrove 3 sides of its patterns. Experiment for 3 times.
Data analysis, we calculate survival rate and growth rate by mean and standard deviation and use one-way ANOVA at level 0.05 to analyze. And soil quality, we include pH, organic matter, soil nutrient, and soil texture. And we analyze by use mean and standard deviation. And we analyze coastal erosion reduction data using the mean and standard deviation. And in terms of coastal erosion prediction data, we're using flow 3D hydro software.
Next is result. Part 1. The result of study on the survival rate and growth rate of mangrove trees planted under different patterns. The first one is the chart shows the average survival rate of mangrove trees planted in different patterns. It shows that the mangrove that plant and under stagger is the highest survival rate, and the study found that the planting pattern statistically significantly affect on the survival rate. And next is the result of average high increase of mangrove tree planted in each pattern over 3 months. The study found that the average increase in the height of mangrove tree planted in different patterns did not significantly different at 0.05 statistically significant level. The chart shows the average increase in circumference of mangrove trees planted in each pattern. The study found that the average increase in circumference of mangrove tree planted in each pattern did not significantly different. And the next one is the chart shows the average number of leaf increase of mangrove tree pattern in each pattern. The study found that the average number of leaf increase of mangrove tree plant in each pattern did not significantly different. And the next part is part 2. The table shows the soil texture, pH, and organic matter contained on the soil before and after planting. We found that the soil texture is a sandy log, and pH before and after is not significantly different, but organic matter after planting is higher than before planting and is significantly different. And next one is the sediment accumulation across different mangrove planting pattern over 3-month period. The study have shown the sediment accumulation increase after planting mangrove, but is not significantly different.
From diagram, it was found that mangrove planted in a stagger pattern can reduce wave velocity uniformly across the entire area. In contrast, the row arrangement show gap or channel that cause the velocity to increase. The semicircular pattern show lower velocity in the central area, but higher velocity along the outer edge of the circle. The control setup show a non-uniform reduction in velocity across different areas.
In conclusion, the staggered planting pattern achieved the highest survival rate of mangrove trees. Statistical analysis at a significance level of 0.05 revealed that different planting patterns significantly influence the survival rates. Regarding growth performance, there were no significant difference in the average increase of stem circumference and leaf count among the different planting patterns. Soil pH levels show no significant difference between pre-planting and post-planting periods. Soil nutrients N, P, and K, and organic matter increase significantly after planting at the 0.05 significance level. The staggered pattern results in the highest rate of sediment accumulation post-planting. The staggered configuration demonstrated the highest efficiency in wave attenuation. The staggered planting pattern proved to be the most cost-effective approach of the mangrove tree restoration. Our research is more than just a scientific experiment. It is a practical solution for coastal communities. By understanding how to work with nature, balancing biological growth with physical protection, we believe that these findings will serve as a valuable guideline for future restoration projects, ensuring that every sapling we plant has the best chance to grow and protect our planet. Thank you for your time and your attention.